Hi children, how are you? I hope my class is safe and I miss you so much and I'm waiting for a comeback day and we all pray the God just quickly wipe out this corona and let us come to school and enjoy and I'm ready to give you so many things after the after this vacation and until that, so we don't want to stop learning and we have to continue learning uh, through this method, through the WhatsApp. I hope you all getting the proper videos and assignments, and if you have any problems, any type of problems or clarity, sound or the things on the board, and you can feed me back, then I can correct and improve my lessons. Okay, I think you can remember the last lesson we have started magnets, and we have studied certain things about the magnets, types of magnets according to their shape, and magnetic poles, identifying magnetic poles, and magnetic field lines. We have studied certain things, magnetic fields. Okay, now we just go to the few applications and further knowledge about magnets. And first of all, the very important instrument that that uses the magnets is compass. A compass is an instrument and used to identify the directions. So find the directions in any part of this world. It's very special thing. There are very special compass, magnets, and the earth. And before we go to the compass, and we have to study about the magnets and the earth. The later I will come, the last session of this video will be about geomagnetism. You know the geo word, geo means earth, geography, and geothermal energy I have studied last time, geothermal, earth's heat. And here geomagnetism means the earth's magnetic power. You will study why earth act as a magnet, and I will teach you the last part of this lesson. And before that, you just keep the earth itself a magnet. Earth is also a magnet. You know, if you take the earth, this is the earth, and you have studied in geography, earth is not just straight and it is rotating in an angle, right? And this angle is 23.5 degree angles. It is rotating in that angle, right? And all these materials are revolving into this part. Last year you have studied about the structure of the earth. Earth has three layers. The outer layer is crust, mantle, and the middle layer is core. The middle layer is a liquid. Middle layer is a liquid. Because of the heat, it has melted down, and then it is being as a liquid. And that liquid is moving, just moving in a circular way. It is creating a circulation in the middle part. So this circulation creates a magnetism around the earth. So if you take this, and the upper part act as a north pole and the lower part act as a south pole, and this magnetic field lines are moving in this way, north to south. And I will prove you how can I tell these magnetic field lines are moving from north to south later in this diagram. Okay, now just simply think earth itself a magnet. It has a north and south pole, and if you take a magnet, not before, just before go to the compass, we just study about the magnets. And take a magnet, any magnet which has a north pole and a south pole, and if you just hang it freely, and if you give a push, and it will rotate or move, and finally it will rest. Always the north pole is facing the north direction and south pole is facing the south direction. And if you try to collapse this setup, and surely you will be tired, getting tired, with the magnet. If you try, if you keep any side and any direction, and if you rotate it, if you push it, if you hit it, and finally it will rest, showing you north and south. There is no doubt. It is a clear thing, and that's the reason, because the north and south, if you keep a magnet here in between, this is the earth, if you keep a magnet, this is north and south, and the magnetic field lines of the magnet and magnetic field lines of this earth will align in one line. Just let me repeat this. And earth is a magnet, it has a magnetic field lines. Magnetic field lines are moving from north to south, and if you keep a magnet any place in the earth, and it will align the magnetic field of the magnet, magnetic field lines of the earth will align in the same direction. It will rest always facing, the north pole will face north and south pole will face south always. And this is a special behavior of magnets. And using this special behavior, we can construct a compass. And you can see, if you take a compass and it is a circular shape or any shape, most it will be circular, and the four directions will be indicated. North, south, east and west will be indicated, and there's a needle is coming horizontally from the center of that circle, and small needle which is with a triangular shape needle, which is magnetized. It has magnetic power, and that needle is kept on the pivot, in the centralized pivot, so it is freely floating. And if you keep any direction, if you shake that and keep any place, any direction, and what will happen, finally that needle will face the red color part of the part of that needle is indicating the north pole, and the blue color is indicating the south pole. And north pole, the red color, always indicates the north direction, and the south, the blue color, will indicate the south direction. This is the special behavior. So later what you can do, let the needle to rest, the facing north and south, and you can rotate that other part and set with the align the north with the red color and south with the blue color, and you can find other colors. And this is how a compass is working. Different shapes, with different look, but the system is same. The method is same, and this method was invented by Chinese people so long ago to find this, find the directions. And now it is very useful. And now this is the compass, and I hope you understood and how the compass is working. The very special behavior of the magnet. All the magnets have north pole and south pole. If you freely hang them or freely float them in the water, you can let it float. Just take a piece of Regifoam and keep it in the water, and it will float, and you can keep a small magnet with north and south, and if you rotate it, finally it will rest. The north red color is always facing the north, and the blue color opposite facing the south. It will rest. This is the nature, because the reason is because earth is itself a magnet. It has a magnetic field line, and wherever you are keeping a magnet in the earth, and it is aligning according to that, accordingly. Okay, so what will happen? How can I prove this is yes, this is true? Then, for example, this is the compass, and if I bring a magnet close to the compass, you can see the changes in the needle, because this compass can be influenced by a magnetic field. If you take it out, and it is aligning in different way, because it is influenced by a magnetic field, and that is the Earth's magnetic field. Okay, let's go to some other parts, right? I told you the magnetic field lines of a magnet is always moving from north pole to south pole. And you may ask me a question, how can you tell that? right? Who the hell are you to tell that? Then I can prove you if you give me a piece of magnet with North Pole and South Pole and few compasses, not only one and few compasses, it is very easy to. Here I have used 1, 2, 3, 4, 5, 6, 7 compasses in this place, and there is a magnet. The red color part is indicating the North Pole and the blue color part is indicating the South Pole, and along one side, and I kept different compasses, altogether 7 compasses I have used, and you can see I think you can see the red color line and the blue color line in each compass. The red color indicates the North Pole, blue color is indicating South Pole. You can see here this is a North Pole, and earlier last year you have studied the interaction between the magnetic poles. Same poles will repulse and the opposite poles will attract each other. Here look at this, North Pole red color and the blue color, the South Pole, are attracted each other. Now you can see here north and south attracted, aligned in one line. That means magnetic field lines are going this way. And you can see when you come here, this is turning a little bit. It goes this way. And further comes down, it is going this way. And here exactly in the middle between the north and south, and the needle is flat. And again it is turning towards the South Pole, and you can see the magnetic field lines are coming out and turning and turn completely and turn towards the South Pole, and it is moving in this way, right? Here it comes finally. This is the direction. The red color is changing this way, and this is how I have indicated. So it is very clear the magnetic field lines are moving from North Pole to South Pole, and I hope you are very clear about the magnetic field means the space around the magnet which has the magnetic power. I think in the last lesson I show you with the magnet. I kept a magnet in this hand and bringing closer some pins. So I kept it here, no attraction, here no attraction. When I bring closer at certain point start to attract, that means its power is limited. If you bring any magnetic material into the magnetic field, then only the magnet can attract. That is the power limit place. The magnetic field lines are imaginary lines where the magnetic power is moving, flowing, or just current. The magnetic current is moving. And then, so using this idea, magnetic field lines, North Pole and South Pole, and we study the geomagnetism, how Earth is working as a magnet. Right, this is the Earth. So imagine this as a Earth, as a 2D picture, and you can see very clearly, and we normally draw the directions like this. This is north, south, east and west. And you have studied last year, Earth has 3 layers. The outer layer is crust, and the inner layer, the middle layer, this is crust, and this is mantle, and finally the middle one is core. Just we combine all the knowledge, and you have studied when you go deeper inside, the temperature is increasing. In the core, the temperature is about 3500 degrees Celsius to 5000 degrees Celsius. Very high temperature, anything will melt. So here the rocks and the elements, metals are in liquid form. Liquid. So this because of this heat, and that liquid is flowing, right? From as a movement is flowing, it's flowing in this way anyway, or they are somehow they are flowing. This flow is creating a magnet. For example, if you take any flow, for example, if you take the magnets and the atoms are vibrating, for your extra knowledge I am telling this, they are vibrating in random directions. But if you can able to vibrate, let them vibrate in all in same direction, it will get magnetic power. So likewise, that is vibrates, the movement. So here the movement of liquid, the magma, is making this as a magnet. So as I told you, the magnetic field lines are coming from north to south. And another very important thing you have studied in geography, Earth is not straight and is little tilted, and it is rotating in this angle. So it is tilted. So this fluctuation is happening this way. So Earth's magnetic field lines will be in this way. So this is north and this is south. So if you keep a magnet, what will happen? Right now, just I'll make it little clear in the middle. To keep a magnet in this part, right? Now what I'm doing is I'm keeping a magnet here in this part. This is north and south, and it has a magnetic field line from north to south, and Earth has a magnetic field line from north to south, and this magnet will rest along with the magnetic field line of the Earth. So both are aligning together. That's why it is always indicating north pole and south pole. So but whatever the magnetic pole is showing you, it is not the actual north. The actual north is here, right? So Earth has two directions. This is the actual north and south, but this is the magnetic north. Magnets will show you a little tilted way. This is called magnetic north, and this is the actual north, right? If you use a magnet, the actual north and the magnetic north has a small difference between this. So if you draw the picture as a bigger, the difference will increase, but in the small scale it is not a big difference. And actually the magnets show you the magnetic north and the magnetic south, but the actual north is little straight, magnetic north is little tilted, and this is the relationship between the compass, the magnets and the Earth, all about magnetic field lines. This is very interesting, and you can search more these quarantine days. You are at home, you are free, and you have a device that you can see the world through that device, and use the YouTube and use the internet and find more facts about magnet. And I will see you in the next video lesson with different types of magnets, temporary magnets and permanent magnets. How can we store and how can we protect the magnetic power, and what are the reasons because of that magnets are losing magnetic power. And see you until then. Bye.